Hello, wonderful celebrity nation. Good day to you all. Today we are working on practice assessment test on the lecture 3, classification of solid matters. Remember our last lecture we treated solid matters. So today we want to run an assessment to know how you understood the course. Question number 1. It says, discuss 3 classes of solid matters. That means if you see this kind of thing in an examination, what it's telling you is state them one by one and discuss them, explain them, give a brief explanation of every one of them. I know within your mind now you are already mentioning them. Yes, I can hear you say semiconductors, conductors. Let's see how it goes. Now, solution to question number 1. I said there are 3 classes of solid matters. Number 1 is conductor. Number 2 is insulator. Number 3 is semiconductor. Now, what are conductors? Conductors are those materials that allow the passage of electricity. That means electric current flows through them. Now, they have large number of free electrons or free charges that can cause conductivity. Examples are copper, silver, aluminum, gold. Mention more. Mention more. You can drop more at the comment section. Now, one thing with conductor too that you also need to know is that it has no energy band gap because the valence band and the conduction band overlapped. So this is for conductor. Now for insulator, they resist the flow of electric charge or electric current. That means electricity does not flow through insulators. The carriers in insulators are not free. They cannot move freely, so they cannot conduct. Example of insulators are rubber, plastic, glass, wood, fabric. Mention as many as you can. You can drop some at the comment section. Now we have the third party here, the semiconductor. Semiconductor has a conductivity that falls intermediate between conductors and insulators. That means sometimes it's an insulator and sometimes it's a conductor. In its natural state, it's an insulator. But when it acquires energy as a result of high or increase in temperature, doping with more conductive elements, you see them conducting. Examples of semiconductors are silicon, germanium, arsenide, and many more. This is question number 1. Now let's look at question number 2. It says, considering movement of electrons only, describe the difference of conductors, insulators, and semiconductors. That means what this particular question is looking for, in case if you see such in your examination, is asking you to differentiate conductors, insulators, and semiconductors based on the movement of electrons only. What are you thinking? I know you're trying to solve that within you now. It's a good one. But let's look at it together. Solution to question number 2. I said, in essence, the difference lies in the ability of electrons to move freely within the material. Conductors, these are materials that have free electrons. Their electrons are free and they can move around. Insulators, they have bounded electrons. The electrons are tightly held and cannot move. Why semiconductors have conductivity in between insulators and conductors? That means at a time, the electrons in semiconductors cannot move. But when an energy is acquired, you see those electrons start moving because semiconductors have two carriers, the electrons and the holes. The holes carry the positive charge while electrons carry the negative charge. So in summary here, we said in conductors, there are free electrons. In insulators, there are no free electrons. While in semiconductors, there is a system whereby the electrons may not be moving, and also when energy is acquired, the electrons can start moving. Question number 3. Which of the following is the most conductive element? A. Copper. B. Iron. C. Silicon. D. Silver. A there, copper is a metal, so it's a conductor. B. Iron is a metal, so it's a conductor. C is silicon, a semiconductor. D is silver. That means at any point in time, any of these may conduct electricity. But let's look at the one that is most conductive. I say the answer is silver because of the nature of the material. Is a conductor, yes. Copper is also a conductor. Iron is also a conductor, but silver is more conducting than the rest of them. Question number 4. A material that has zero resistance is called dash. When a material has zero resistance, what does that mean? It means that it has full conductivity. When there is no resistance at all, that means everything about that material is conducting. So it's not insulator, it's not conductor, it's not semiconductor. I think it's superconductor, but let's check. Now that is the question. A material that has zero resistance is called dash. And I say the answer is superconductors. Why? Because since there is no resistance at all, that means the conductivity is at 100%. Question number 5. Why is copper a preferred choice in making electrical wires? Option A, it says copper is a good conductor of electricity. Option B, copper is a poor conductor of electricity. Option C, copper is an insulator. And option D says copper is a superconductor. Now we want to find out. Copper is a good conductor of electricity. And that is our answer, option A. Copper is not a superconductor because it has some resistance to current. Copper is not a poor conductor of electricity. No, it conducts electricity perfectly well. Copper is not an insulator because it conducts electricity. So the answer is A. Copper is a good conductor of electricity. Question number 6. Which among the following is not an insulator? Which among the following is not an insulator? What is this question trying to ask you? It's simply asking you to pick out from these options which of these conducts electricity. Because when something is not an insulator, that means that thing is conducting electricity. And the options we have here, we have wool, we have plastic, we have silver, we have paper. Aha. Which one is your answer? Wool, plastic, silver, or paper? The answer is silver. Why? Silver conducts electricity. Wool is an insulator. It does not conduct electricity. Plastic does not conduct electricity. Paper does not conduct electricity. But silver is a metal and it conducts electricity. So it's not an insulator. Question number 7. What is the inverse of resistance called? A. Inductance. B. Conductance. C. Resistivity. B. Permittivity. The answer is conductance. Because if a material is not resisting current, then it's conducting current. So, opposite of resistance is conductance. Opposite of resistivity is conductivity. Note that today. Question number 8. The energy gap is maximum in dash. The energy gap is maximum in dash. A. Conductors. B. Semiconductors. C. Insulators. D. Superconductors. Let's look at this critically. In conductors, the energy gap does not exist. Why? Because the valence band and the conduction band overlapped. In semiconductors, yes, there is energy gap, but it's small. In insulators, we have large energy gap. In superconductors are conductors, so there is no energy gap. So I think the answer is C. Let's look at it together. Answer C, insulators. Question number 9. Conductors are materials that dash. A, allow the flow of heat. B, does not allow heat to flow. C, allows cold to flow. D, stops cold from passing through. The answer is A, allow the flow of heat, because conductors, despite the fact of allowing the flow of current as electricity, allows the flow of heat better than insulators. Question number 10. Good conductors have many loosely bound dash. When you say a material is a good conductor, what does that mean? Does it mean that the atoms are loose, or the protons are loose, or the molecules are loose, or the electrons are loose? That is what is asking you here. But remember, we'll say that conductors have free electrons. That means the electrons are loosely bound. So the answer is D. Question number 11. The resistance of the conductor is directly proportional to dash, length, area of cross-section, temperature, or resistivity. The answer is length. If you get the equation of resistivity, you see that resistivity is the ratio of the product of resistance and area to that of length. Now, if you arrange it well, you will see that resistance is directly proportional to length. Question number 12. With the increase in temperature, the resistance of semiconductors dash. With the increase in temperature, the resistance of semiconductors dash. A, decrease. B, increase. C, remains constant. D, initially increase and then decrease. What is the answer? Make your choice. The answer is A, decrease. Yes. When you increase the temperature of the resistance of a semiconductor, when you increase the temperature of the semiconductor, the resistance of the same semiconductor decreases. Question number 13. Which of the following is an insulator? A, brass, B, copper, C, gold, D, glass. Without any thinking, I believe you can give me answer to that. The answer is glass, D. Question number 14. What are the charged particles in a conductor free to do? A, reflect light. B, stay stationary within the atomic structure. C, absorb energy from the circuit. D, move around and flow as an electric current. When you say that the particles, the charged particles, example electron, that they are free in a conductor, what are they there to do? Certainly, they move around and flow as an electric current, because that is what enables the conductor to conduct electricity. Question number 15. What is the term used for materials where the charge carriers are locked into the atomic structure and not free to move? Thermistor, semiconductor, insulator, conductor. The answer is insulators. Let's find out whether it's true. Yes, insulators. Because insulators have bound electrons. That is why they cannot conduct. Their carriers are not free, so they cannot conduct electricity. Question number 16. What is the term used for a material that can be a regular conductor or not depending on the energy given to it? A, thermistor. B, semiconductor. C, insulator. D, conductor. Yeah, I can hear you say the answer. So what is the answer? Conductor. Answer D. If your answer is conductor, you're correct. If you did not choose conductor, you're wrong. Question number 17. Considering the energy band gap, describe the difference of insulators, conductors, and semiconductors. Now, this one is asking you to differentiate conductors, insulators, and semiconductors using the concept of energy band gap only. Now, let's look at the diagram on your screen. If you look at that point on my left, you will see that that's a metal, and the energy band gap there does not exist. Energy band gap is more like a column where electron does not stay, does not exist there. So there was no conductivity or conduction in that area. So there is no energy band gap in a conductor. That is why the valence band and the conduction band overlapped. So conductivity occurs at every point in time. Conduction continuously occur at every point in time. Now look at semiconductors. You will see a band gap, yes, but it's small, such that electron that acquires energy from the valence band can move to the conduction band with ease and conduct electricity. This is semiconductor. Now, for insulators, you can see that the band gap is quite large. And even when electrons acquire energy, they cannot jump the band gap to get to the conduction band in order for it to conduct. So, in summary, conductors have no energy band gap. Semiconductors have small energy band gap, while insulators have large energy band gap. So if the band gap, question number 18 says, if the band gap between valence band and conduction band in a material is 5.0 electron volts, then the material is dash. Is it semiconductor? Is it good conductor? Is it superconductor? Or is it insulator? Let's analyze. And I said the answer is insulator. And I know as a wonderful student now, you'll be telling yourself, how? Why is it insulator? 5.0 electron volt. Why is it insulator? Okay, what if I have 3 electron volt? What if I have 10 electron volt? What if I have 1 million electron volt? Let's try and explain. In conductors, the valence and the conduction bands either overlaps or are very close in energy, meaning electrons can easily move into the conduction band with minimal energy input. This leads to high electrical conductivity. In fact, in conductors, the energy band gap should not be up to 3 electron volts. It shouldn't be. It should be quite small. It should not be up to 3 electron volts for it to conduct. The energy band gap shouldn't be more than that. Now, for insulators, they have a large band gap, typically greater than 3 electron volts, making it difficult for electrons to gain enough energy to jump into the conduction band. This results in very low electrical conductivity. Now, since the energy band gap in insulators is more than 3, and in the question, they said, look at the question again. If the band gap between valence band and conduction band in a material is 5.0 electron volt, then the material is dash. And they said here in insulators that the band gap typically must be greater than 3 electron volts. And 5 electron volts is greater than 3 electron volts. So the answer is insulator. Question number 19. What is the relationship between the energy band gap and conductivity? What is the relationship between the energy band gap and conductivity? Let's look at it. The relationship between energy band gap and conductivity goes this way. The greater the energy band gap, the lower the conductivity of the material. What is this band gap? We said it's the energy required to promote a valence electron bound to an atom to become a conduction electron. So, the energy band gap is the barrier between the valence band and the conduction band. And a material can only conduct when an electron moves from the valence band to the conduction band. So this barrier now, the smaller it is, the easier for an electron to move over. But the bigger it is, more difficult it will be for an electron to move over. So we say the conduction electron is free to move within the crystal lattice and serve as a charge carrier to conduct electric current. Yes, electron can only conduct when it's at the conduction band. So let's look at this together. Just like the first diagram we discussed, if you look at the metal here, you will see that there is an overlap between the conduction band and the valence band. So it's constantly conducting. You look at the semiconductor, the energy gap there is quite small. So it may not be conducting initially, but once energy is acquired through certain processes like increase in temperature, doping, certainly it will conduct, because once the energy is greater than the energy band gap, it will pull over. It will go over and conduct. But now look at insulator. The energy band gap is quite large. So the more you acquire energy, you cannot acquire energy that is enough to pick electron from the valence band to the conduction band, thereby leaving that particular material non-conducting. Assignment. Please This is an academic program, and I would like you to take this assignment serious. Write on the comment section 3 classes of solid materials and 1 example each. I repeat, write on the comment section. See it as a practice. Make sure you do it. 3 classes of solid materials and 1 example each. And if you have not subscribed, don't fail to click the subscribe button now. It costs you nothing. Now, if there is still anything you did not understand in this lecture 3, even after this assessment, please feel free to drop your feedback question at the comment section. Have a wonderful day. May the Almighty continue to protect, guide, lead you. Don't forget our goal. The goal is that A we must have in Physics 102. Thank you and have a lovely day.